Now it seems to work. Very good. So you should get a pop-up, everyone. That's our YouTube live stream.
Just come on. Live stream.
So yeah, welcome everyone this morning to another Open Digital Health event. My name is Sebastian Potthoff and I'm a director at Open Digital Health, and I'm also joined by Zini, who's part of our events team. And yeah, we're really happy to welcome you to another event. Just as a little bit of housekeeping, we are always recording these events so that we can share them widely afterwards. If you can, please keep your microphone muted during the presentation, and then there will be plenty of time, second half of this event, to just have some informal discussions. So if you have any questions about today's presentation, maybe just write them down, keep them in mind. So do think about something you would like to talk about, because we try to keep it quite conversational, but we will do that sort of at the end of the session. Yeah, so today it is my absolute pleasure to welcome Dr. Janna Hastings, who is today's speaker. So I'll just introduce Janna and tell you a little bit about her. I was very lucky to meet her this year at the European Implementation Conference, and was lucky to hear about her research and thought she would be great to talk to us at these events. So Dr. Janna Hastings is an assistant professor of medical knowledge and decision support at the Institute of Implementation Science in Healthcare at the University of Zurich, and a vice director of the School of Medicine at the University of St. Gallen, also in Switzerland. The focus of her research is on digitalization in the clinic and how new digital technologies can be harnessed to accelerate biomedical discovery and improve the working lives of clinicians. And today, Janna will talk to us about a very kind of cutting edge topic, AI actionable knowledge from evidence synthesis to prediction of behavior change intervention outcomes with the Human Behavior-Change Project. So at this point, I will hand it over to Janna.
Thank you so much, Sebastian and Zini, for inviting me to talk today. And today I will try to talk about this topic. I think everybody is interested in AI at the moment, and we try to solve practical problems, but it can be quite challenging. So let's see. So the overarching perspective for this work is the kind of idea that it's essential to achieve behavior change because human behavior is the sort of one of the main drivers of, or one of the main modifiable drivers of many of the global challenges, such as health and climate change. This picture here was generated with an image generation AI, and I asked it to kind of fuse the idea of lifestyle, health-related behavior with climate change. So we have here somebody going for a jog in a forest that's burning down. So sorry if that's a little bit dark, but maybe it's a metaphor for much of the work that we try to do. We're trying to tackle kind of big challenges. There's a lot of evidence about human behavior change. So there's a lot of research into human behavior change, which tells us what kind of behavior change interventions work, really help people to achieve lasting behavior in different situations, in different contexts, different types of behavior. But this evidence is very difficult to access. One reason is that there's too much of it. So there's simply an overwhelming amount of evidence being published every year, every day. And then another reason is that the evidence base is itself kind of heterogeneous in the sense that things are described differently, and you never, without really drilling in great detail into the methods or supplements associated with given studies, you never really fully know what was done. Sometimes what was done is under-described, even if you drill into all the details. And this illustration, which accompanied this paper in Nature 2 years ago, kind of supposed to give an idea of this, a visual illustration of this challenge of policymakers and practitioners and everybody trying to make a difference, trying to catch this overwhelming evidence monster as it runs away, right? So this is the challenge. Too much evidence, difficult to navigate, difficult to get an overview and a really integrated perspective on what changes behavior most effectively in a given situation for a given behavior. So this problem was the motivation for the Human Behaviour-Change Project. This is a large-scale collaborative award funded by the Wellcome Trust that ran for 6 years up until May or June of this year when we finished and launched the associated tools, but we're still conducting research and continuing with development of the tools. So the aim of the Human Behaviour-Change Project was to use digital tools to create and sort of semi-automate evidence synthesis for the domain of behavior change. I just mentioned briefly the scale of the collaboration and some of the key people involved. So the project is led by Susan Mickey of the Centre for Behaviour Change at University College London and a team of behavioural scientists. There were also a team of computer scientists and systems architecturalists who sort of made sure that everything fitted together. I was a consultant on the project all the way through and helped to develop some of the key technologies, which we will discuss. So the vision of the HBCP is to develop a kind of broader, synthesized understanding of human behavior that enables actionable answers to be derived from evidence for questions of this form. What works to change behavior? Compared with what? So, of course, studies which try and figure out what works, they are done comparatively. For which behaviors, how well? So what is the size of the effect? For how long? How long is the duration of the effect? And other contextual factors, with whom, in what setting, and with what mechanism. So why? And in order to answer this question, the idea was to develop a knowledge system, so a digital system, which consisted of the following components that together would allow questions of that form to be answered. An ontology for the whole domain, so a formal computable specification, and I will talk more about that in a little bit. This sort of represents knowledge that allows you to structure the evidence and the data. An automated system to extract information from the published literature, a database containing information from these reports that has been extracted, machine learning and reasoning algorithms that are able to synthesize the information. This is the kind of AI part of the story. And then some, obviously, interfaces which allow people to interact with the system. So I just wanted to pause again to say this is what my favorite image generation AI came up with when I gave it the topic of this talk. So that I said, think about synthesis of evidence about human behavior change from evidence to predictions. And it gave me this quite mystical perspective of some people sitting and thinking very hard, and you can see the sort of evidence, I guess, in the background, and they're thinking very hard about this bubble above their heads, but that was just for fun. So what we have as the kind of vision of the system is that from your messy evidence, you provide an organizing structure and you add algorithms which allow you to interpret the data and the evidence according to this organizing structure. And from that, you get out well-organized and useful scientific insights. So this good vision. And now in practice, what we have is several components of a multi-component system, which are in a way a little bit separate and then plugged together to make the overarching pipeline. So we have one component which is considers information extraction, so getting from published papers some kind of structured information out. We have another component which is concerned with storing information, sort of organized information. And then we have various components which provide several analytics on top of this. such as search, prediction, recommendation, etc., etc. And all of this is made available as an online system. So now I want to talk very briefly about the organization of the knowledge, which is the ontology part, as this is really a key and crucial sort of fundamental component of the overarching system. So first, for those who don't know what ontologies are, these are knowledge representation structures that are widely used in other domains, such as in the biomedical domain, to capture in a shared and computable way the essence of the subject matter of a domain, the actual things like the chemicals or the behaviors in our case, in a way that you attach a definition to every entity and you interrelate everything so that it's clear what you're talking about when you're talking about something in a kind of unambiguous way. And then you can use these to annotate all sorts of different data. And because you have common annotations, you have a common view of all of these different types of data. So we aim to develop an ontology for the behavior change intervention domain. And this is a sort of high-level overview of the subject matter. So you have a scenario, which is a behavior change intervention scenario. And this is multifaceted. It consists not only of an intervention, which itself can be broken down into content, the actual intervention, and the delivery, so how it's delivered. But then you have some other additional features which relate to the context, such as who is the population the intervention is being delivered to, what is the setting, what is happening in the world at that time, which may be influencing the outcome of your intervention. And you have the mechanism of action, which is a process of change, right? And around all of this, you have a study, which is telling you what are you comparing with what, and what is the essential finding of this study, and you have various methods. So this high-level overview is then populated further into and starts to look maybe more detailed, but I won't be able to go into all the details at this point, but the basic idea is that from these entities, you then go further and further down, breaking it down into its component parts and different aspects and giving each of them a definition. So within the delivery, you see you have also the source, which is who does the delivery. Within the setting, you see that you have also a distinction between physical settings or social settings and so on. So you get the idea that you break down and sort of describe in detail the entities that you may be referring to. And this process of capturing the sort of semantic structure of the domain then allows you to do all sorts of interesting things with the knowledge that you've captured afterwards. So this overarching behavior change intervention ontology has several different components, each of which has been further developed. And these were sort of the same as the illustration was showing the upper level of before, but each of them has a separate module within the overarching ontology. So here's one example, what it looks like at the level of the details. You can see here visualized a hierarchy for mode of delivery. That's how is an intervention delivered. And then you have many different aspects for how it can be delivered, such as, for example, gamification is one mode of delivery. Face-to-face is an attribute, or at a distance, and so on. So you see, you get really to the level of the details. Each of these terms is given a definition. Each of these terms is given a unique identifier, so it can be used in a consistent way across databases. A little bit of extra plumbing. I skip over some more of these examples. Now I'll switch to start talking about the evidence synthesis. So we've got now an ontology which describes the semantics of the domain, and the objective is to use this ontology to extract information consistently out of the literature in order to put that information together and make predictions based on it. So the raw data for the evidence synthesis is randomized controlled trials, and the Human Behavior Change Project emphasized smoking cessation trials as its first case study. Although the technology is in principle usable for a multitude of different behavioral outcomes, smoking cessation was chosen because the literature is relatively consistent and coherent, and it's one kind of target that is achievable as a case study. So here you see the raw material, some examples of laid out text in PDFs. And from these PDFs, a lot of the relevant information is embedded in tables, which may have a heterogeneous and variable structure, and in methods, which are in free text, and extracting the computable description of what was done in a kind of semantically consistent way is completely not a trivial task. It's really not straightforward at all to get from this to this, which is really a shame, because the researchers, when they're preparing the study, they have the information about the sort of structure and semantic description. So it's a little bit information loss that then we go and have to go from these PDFs, which are designed to be visually pleasing rather than semantically structured, and again try and extract a kind of coherent semantic structure. But I will not talk mainly about the information extraction challenge today, but rather about the prediction challenge, which is sort of assuming you've got some semi-structured data and text about an intervention, then sort of building a system which is able to use that information, synthesize it, and predict an intervention outcome based on the evidence. So what we do is we take the evidence coming from the PDFs and we associate different parts of the evidence, the PDF, with the semantic description from the ontology in a consistent way. And there are different types of annotations in this basis. So you can have just whether or not a feature was used, but you can also have features which take values, and features among the features which take values, you have some which take numeric values. And these different types of annotations are used differently afterwards in the ultimate prediction system. Then we aim to build an interpretable prediction system, because a black box system is for the purposes of policymakers or intervention experts. It's just not useful to have a black box system which doesn't explain its predictions. So I skip over this. Basically, this is telling you about how we build up the database from the evidence with the ontology, and what our objective is to predict the intervention outcomes together with explanations. So when we looked at sort of surveying the literature on approaches to interpretable machine learning, what we discovered was that so of course, most machine learning AI approaches that are really large scale and working with big data sets, such as the image generation examples, which I showed earlier, they work in some sense as black boxes. They have so many internal parameters that it doesn't really make sense to try to understand them. So what people sometimes do is they sort of bypass a prediction network with a method which gives an explanation after the fact, and this is called post hoc interpretability. But this is unsatisfying because you never have any guarantees whether the predictive network was actually using the method that the explanation gives you, or if this is just made up like some kind of cognitive rationalizing after the fact. So then you have what's called glass box approaches, which are built in a way that you can see and inspect the inner workings of the model. So we elected to go with a glass box approach, and we chose to work with a rules-based system, because rules-based systems, so systems where what the model learns are rules in terms of the features which the model has to work with, these are considered the most naturally understandable for humans. So if you think about it, we do tend to think explanations have quite a natural fit with rules such as, well, if the age is greater than 50, then the effect will be more or less by a certain amount. That's the form that these kind of systems work with. So we built, and actually we had to develop a slightly novel approach to get exactly what we wanted, but we built a system where we learn rules in terms of the features coming from the evidence base, but we learn it using a kind of more modern machine learning optimization approach compared to the historical literature of rules learning in machine learning. And what this means is that we think we have quite a good system, and quite a good system that is able to be trained based on data, but it also follows the structure, which is semantic given in the ontology. And in the end, you get out a prediction of effectiveness of the intervention, of the smoking cessation intervention, but you also get out explanations in the form of which rules were used to make that prediction. So each rule is only partial. You need a set of rules in order to make a whole prediction. And then you sort of add up all the tiny mini effects of each of the set of rules. And this gives you your overall prediction. So this system, I think here it will be much too small for you to read, but I just explain the overall interface and then you get an idea of what's happening. So this prediction basically allows you, so the model is trained based on the evidence, which is extracted from the literature. And then the model is able to provide predictions in situations, because it's a machine learning predictive model, in situations that were not in the literature. So here in this interface, you specifying a kind of situation or a behavior change scenario, which may or may not correspond to actual studies. So you're specifying your population, mean age, the mean number of times tobacco was used, so how often they smoked, and whether the study had continuous, et cetera, et cetera. These are the characteristics of the study. And these characteristics are applied both to your predicted control group and your predicted intervention group. But then on the left-hand side here, you select which intervention elements you apply in your study. So you can choose, for example, among all kind of different intervention elements. These are behavior change techniques, goal setting, behavioral, contract, pharmacological support, and so on. And then what you see here in the lower box is the kind of baseline for your study, the predicted baseline. So based on your population features, you have some sort of percentage which is predicted to be the baseline quit rate for this study. And then you apply your intervention features on top and you get out a predicted intervention quit rate. Now, the model is certainly far from perfect. It's trained based on limited data. It's very noisy data. So even a good model is subject to big variability just based on the noise in the underlying data set. And sometimes we see effects which are based on the setup of the problem. So for example, sometimes we see negative effects for intervention features where we think that probably the intervention feature would have a positive effect. But the reason the model is learning a negative effect can be because that intervention feature is often appearing in control groups and not appearing in actual intervention groups, right? So you have some sort of biases in your underlying literature in terms of what's been studied that we are not able to fully correct for. But overall, we find that the predictive power is not bad given the noisiness of the underlying data set. And we think that this is potentially the way forward to provide such a utility based on the evidence, all the way through from evidence through semantic characterization into training a model and then having actionable ultimately knowledge that you can then decide which is the right intervention for my particular population group. So that was a short overview. I apologize for the brevity, but now we have time for discussing. I just want to mention that there's a collection on Welcome Open Research devoted to the Human Behavior Change Project, and there are many publications which go into more detail about the different aspects of the project there. And that two of the things that we're currently working on, we're working on physical activity as a sort of second case study after smoking cessation. And there's another project we're working on where we're trying to bring a bit more of a similar approach and a semantic description to the domain of mental health, which I think is really exciting. So once again, thanks to my wonderful colleagues and collaborators, and thank you for listening.
Thank you very much, Janna. That was really, really nice with the tour through the behavior change ontology. So really interesting work. Yeah, at this point, I would like to open it up for any questions from the audience, any comments. We get some applause here, digital applause. So people enjoyed it. Okay, we have somebody,
Hello, thank you so much
Hi.
for the presentation. Yeah, it was really interesting. I was wondering if you kind of see the future of these things. I guess you were saying with the way that we kind of write journal articles and people are describing things in their kind of own language. I wonder if you kind of see in the future, as well as maybe writing journal articles, that almost there's like a form that you fill in that kind of is sort of preset to these criteria, I guess, to try to make this kind of evidence more usable and accessible in the future.
That's right. Absolutely. 100% spot on. So in the biosciences, for many different aspects of the sort of research and the knowledge which people generate, it's mandatory as a part of some community organizations have agreed that when you do research and submit a paper, that you also have to submit the associated data in some open repository and annotate it in a structured way. And this, I think, has massively accelerated some aspects of genomics research, of bioscience research, in a way that just wouldn't have been possible if the community hadn't decided to make those agreements. So I think in behavioral sciences, we're not in that situation right now, but it's possible that more and more people are waking up and thinking that this would be a really good idea. And then, of course, you need to have the right tools and the right infrastructure, as well as the community agreement and sort of getting behind it. So if it were the case, if it were possible to have a form associated with a publication where you capture this information as an author from a structured perspective straight away, and then it goes into a sort of central knowledge base directly, I think this would really transform and accelerate the translation of evidence into actionable knowledge. One of my collaborators at UCL, Professor Robert West, has been working on what's called a paper authoring tool. And the vision for the paper authoring tool is exactly to be a kind of form which is easy to use, in which you can capture a semantic representation of your research, and it's linked to ontologies.
Great question. Thank you, Lucy. I had this one put down as well, and another one that I had that kind of relates to that maybe a little bit, because you said that kind of two of the main problems that you have is sort of like the noisy data that you're getting and kind of inconsistent reporting. And then I suppose that there are kind of evidence gaps as well, right? Like where we just don't have any systematic reviews available. So to what extent do you think this kind of work can help show us some of the blind spots that we have with regards to studying some sort of intervention? can it maybe help us identify, okay, these are the things that we still don't know about, and therefore kind of direct future research? Do you think there's some potential there?
Yeah, I definitely do. So I think there's, so the prediction system, which I focused on mainly during today's talk, I think it doesn't directly show gaps, and even could mislead a little bit, because you can't tell directly from the prediction whether it's based on a lot of evidence or it's extrapolated, right? Because the model has learned to generalize from the evidence that it's trained with. But I think that the sort of annotations, the structured annotations of the underlying literature, these are really key to understanding, having a map of what the literature shows. And we do have a separate tool, which I didn't present today, which really just shows that. It shows like how many papers for each annotation have been published, are being published, and so on. And from this kind of map, you can also see gaps. But I think there's an even broader question, which is not only where are the gaps, but where are the inconsistencies? I think sometimes you have evidence which is actually contradictory, right? Where you have one study showing that such and such a technique works for such and such a context and population, and then another study showing that it doesn't work. And this is really the hard work of evidence synthesis, trying to figure out why. What is the reason that we see this heterogeneity? And I think that these tools and approaches can help to highlight such inconsistencies, which require further research kind of urgently, I guess.
Yeah, great. Any further questions from the audience? Another one from Lucy. Go ahead, please.
Sorry.
That's all good. Yeah.
Lots and lots of questions. I was wondering what you think the kind of impacts of publication bias might be on a tool like this. So I guess we know that there's a bias towards publications of papers that show a kind of significant outcome, but then also, I guess, selective reporting of outcomes by the researchers themselves. So I was wondering, if you think those two things are having an impact on the model.
Absolutely. I think it's part of the reason why the underlying data is noisy the way that it is because negative results, or results that are less favorable to whatever the researchers are trying to show, are simply absent from the data set. And so you have to infer the sort of potentially negative results. You're inferring a lot from your control group. So you have this sort of setup where, depending on the role within the study, you may see different effects. And we try to control for that by explicitly differentiating which parts of the underlying data were from the control group, which parts are from the intervention group. And we know that, in addition, control group interventions are under-described. Study authors tend to focus on more consistent descriptions of their intervention condition than their control condition, and so on, other problems like this. But yes, ultimately we are limited by these biases and problems in the underlying evidence. And to the extent that the raw material becomes better, or we're able to gain evidence with less bias, then certainly the model that we're able to build will also become better and more predictive.
Very good question. Thank you, Lucy. One question that I always like to ask as well is, and you started your presentation with that, with the constellation of your team, how multidisciplinary it was, and you had these architecture experts, computer scientists, behavioral experts. how was it? Yeah, there they are. How was the collaboration between all of those different people that I'd imagine some of them speak a little bit different languages? Was there any kind of challenges around that?
Absolutely. In fact, this is, I think, one of the big learnings of the project as a whole was around interdisciplinary collaboration. So the proposal and the funding from the Wellcome Trust really favored, I think, required interdisciplinary collaboration. So that was what the funding was kind of asking for. But also to do what the project aims to do, it requires interdisciplinary collaboration. But along the way, there were many challenges that were arising from this interdisciplinary collaboration, which were quite deep, and we will, I think, probably be publishing a kind of commentary which really talks about this, but I can give just some general thoughts or experiences that I can share. So one aspect is, so the ways of working and doing research at all are quite different between behavioral science with trials and studies and so on, and computer science, where you're building things, you're trying to engineer things and make them sort of, it's really quite a different frame between, let's say, trying to discover things about the world or trying to create new things in the world, right? And the systems architecture being more on the side of bridging between users and pure computer scientists. Pure computer science is a lot about, you know, what is the next big architecture that's going to really revolutionize all the different use cases. And so some of the challenges that came up were that, for example, members of the computer science team had trouble understanding really the overarching scientific framework of trials, of randomized controlled trials and so on. It's just not something that they have to do ever or read ever. And so things like having one arm or multi-arm and all these different intervention design, study designs and so on were just Greek to them, more or less. And on the other hand, the sort of complex technical aspects of one architecture or one model compared to another one were definitely Greek to the behavioral science team, and they were not very interested either, I think. So there were these big gaps, I think, in communication. And my role as a computer scientist who is also a psychologist was, or became at some point, to sort of help bridge gaps between and translate things. And I think we definitely came out with the feeling that, so I wasn't the only one who was a bit more interdisciplinary in my background, but we definitely came out with the feeling that you need several people who are able to speak multiple languages to make such a project a success. You have to have several different types of bridges, because you cannot equip, in the space of a project, you cannot equip every team member from single discipline perspectives with all the background they need to understand the other perspective completely. So you have to be able to translate effectively and resolve conflict.
Mm-hmm. Mm-hmm. But that's fantastic that you managed to get these learnings out of it. And I think with these kind of projects, really, you're making sure you're not just working in a silo and you know, have your own only that one lens on, because you know, ultimately, if you have such a diverse team, you'll probably build something that is, in the end, more translatable, right? That will actually make an impact. And I could imagine later on there will be further columns of people, of policymakers or practitioners who will be involved to see, you know, what kind of value do they see in this infrastructure, and what are the questions that they would ask the ontology, right? And absolutely. I'm sure you had that in the back of your mind as well when you were designing it.
Yeah, no, that's absolutely right. There is, so we have gone a certain sort of distance, but there are there's much further to go towards, real use cases of policymakers, in the sense that the way that they want to ask questions is probably still not quite what we're providing, right? There's a whole extra layer around a prediction, which is still missing. And indeed, in the future, we can think how we can add that.
Great. Do we have any more questions from the audience? Please feel free also to post them in the chat if you like, or just stick your hand up. We can have a chat. Okay, Lucy is saving the moment again. No, go ahead. If nobody wants to chat, that's fine. We keep the conversation going.
Yeah, if anybody else wants to, please, tell me to be quiet. But yeah, I was wondering, do you see kind of the way that the tool is used at the end is that with those predictions, that for policymakers, that's kind of how they then develop interventions, or that kind of from those predictions, the interventions are developed that then go on to be tested in a clinical trial before being implemented? Or I guess a middle ground of like a real world evaluation?
Yeah, I think so. What we've been aiming for is a tool that can give hypotheses. So based on the evidence and the synthesis of the evidence, you can come up with some sort of prediction or hypothesis about how it might pan out if you were to do a particular study, because it's a generalization based on the evidence from the studies that you have. Now, policymakers will probably be interested in additional questions such as, okay, this is what I want to do, and these are my constraints. So you want to have a kind of semantic specification of where you have flexibility and where you don't. And then they'll want to say something like, what are the best 2 or 3 candidates for sort of intervention strategies in my constrained scenario that I should explore? Sorry. So I think that this idea of the digital system as a kind of exploration tool and interactive and dynamic, I think this enhances the potential for policymakers to sort of explore their thinking about a particular problem area where they want to implement something. But at the moment, in order to use it that way, there's still a fair bit of work they would have to do to think up what are the scenarios, what are the possible parameters that can change. And I think adding a layer around the interface could support that use case better in the future. I don't know if you have thoughts or comments or suggestions about that.
No, I mean, it sounds really interesting. And I think, as you said, very useful in a situation where you have predefined constraints on the intervention. Kind of, yeah, allows you to say, well, in this scenario, what might work. So yeah, I think that makes a lot of sense, and I guess it'll be really interesting once other sort of areas are added to see, I guess, what commonalities there are and where there are differences between different populations and conditions and kind of what works there. Yeah, absolutely. Really exciting. Like, the value of this kind of approach grows the more data you can put in it, and the more then you can do more kind of algorithmically as well, probing which parts of the evidence base generalize where and which don't. And yeah,
I think something that I find exciting as well is you were talking about the glass box approach, in the sense that actually in the end, we're working towards a system where it's AI generated and it's very complex, and for the regular person it's probably very hard to understand, but alongside that, to work on some logic sort of that is also generated that makes it really understandable for the lay person, I suppose. I think that's something that will ultimately also help generate trust in these systems, because if you have a team of multidisciplinary researchers working on this, experts, you have this kind of control what you sort of feed into it. You can be more explicit about the things that you are uncertain about, and then you can also like give a little bit of an rationale what has actually happened in the system to generate this hypothesis or statement. So therefore it's not just, okay, we have this ultimate technology and it gives us this perfect answer, but it's just like a little bit more, makes it a little bit more transparent, I suppose.
Yeah, exactly. So I read an interesting article recently that was showing some evidence that it's actually harder to make a transparent predictive model and to make that into a success. But if you manage, then they will be more used. And the argument was along the lines that when people can see really what the model is actually doing, they're much more likely to find problems with the data, problems with the prediction, and so on. And then, of course, it takes much longer and is much harder because you have to go and resolve those problems. But if you're training a black box, your problems are invisible, and you have no way to know whether the predictions that are made are well-founded or problematic in some sense, because you can't see the inner workings. So it's then you can say this is the magic machine which is giving you the answers, but ultimately it's not good enough. It's not satisfying. And I think for most real-world decision-making contexts, I mean, unless the model has close to perfect performance, it's hard to see how it's so helpful if you can't get some insight into what it's based on, right?
Yeah. Really interesting. Any more questions from the audience? Well, we have Janna here. No? Okay, no problem. I think they would have come up with a question by now. We had a lot of time we gave them, so no problem. I think they were just very fascinated by all of this information, and really great to have an expert like yourself present as part of this event series. So thank you very much again for coming along and giving your time.
Thank you so much for having me. I'm really excited by the network and the work that you guys are doing.
Thank you. And thank you everyone for coming along to this event. We will have another one coming up next month. So keep an eye out for the invite. I think it already went out, and our social media channels to see all of the new stuff coming up. And as always, we recorded this session, so we'll make it available as a recording if you would like to share it with your friends and colleagues. Other than that, I hope everybody has a fantastic rest of the week. See you later.
Super.
Thank you. Bye-bye.
Bye.
Bye-bye.